All right, good morning, good afternoon, or good evening. Welcome to the second CNDM webinar, or should we call it CNDM stream. Super excited about this series. Previous watchers have been giving us great feedback, and I really like the convenience of this streaming platform. Also super excited about our speaker today. Paul Speciale from Scality has an impressive track record in this industry, and he's got a lot of great knowledge to share. He was an early cloud computing innovator. He helped build the object storage space, and today Paul is Chief Product Officer at Scality, who are an innovator in cloud-native storage. So this streaming platform, which we like a lot, aims to allow people to watch webinars when it is most convenient. That doesn't mean, however, that it needs to be less interactive. Viewers who are with us live right now can ask live questions. You have the comment section for that, and we will address those questions live at the end of the presentation. But people who are watching this webinar on demand can simply ask questions in the comment section, and we will answer those questions when we can. So do not hesitate to post those questions in delay. Without further ado, let's get started. Paul, to begin with, can you give us some background and context on Scality? Where do you fit in the market?
Sure, I will. And let me first say that I'm really happy to be here, and we really do believe in the charter of Cloud Native Data Management Day. We think the community is a great idea and a great effort. Where do we fit in the market? Well, we've been around now for about a decade, actually just over a decade, in the scale-out file and object storage space. So people would know us for a product called Ring. It's really all about providing a way to store, protect large amounts of data, meaning petabytes of data for long-term with high reliability, and to do that at low costs. So think of us as a player in that big capacity storage space.
All right. And that was very helpful. Thank you so much. Can you give us some insights in how cloud native is becoming more relevant for you and your customers?
Yeah, absolutely. And I think, having looked at this market now for the 10 years plus that I talked about, there was really a very noticeable change about 4 years ago, I would say. One inflection point for us was when we were attending a lot of the big cloud shows. People started saying, we need a way to manage our data both on-prem and in public cloud. That was one of the trends that we heard. The second one was really this emergence of container-based software. We started hearing about people using Docker and Docker Swarm and Mesosphere, and we started thinking ourselves about how to address the requirements of this space. I think one of the big things that happened is we started seeing more customer workloads being deployed in Kubernetes as containerized services. And I think for us, that changed a lot of the workload patterns, the data types, and how the storage should be consumed. So that's really the big inflection point that we want to talk about today, is how does that whole cloud native workload change the demands on storage?
All right, awesome. That's great. Well, sounds like you've got a lot of good content for us today. So why don't you get started, and I'll have some more questions for you at the end of your presentation.
That's perfect. That's perfect. Thanks a lot. All right. So I think, the context I just gave is kind of the high level, but let me kind of peel the onion on a little bit. What we really want to focus on is how do we manage storage and data specifically from this new world of cloud native, right? And one of the key things is we have to kind of look at what are the business drivers. So let's just spend a few minutes on that. But then I'll dig a little bit deeper and talk about what types of workloads we've been seeing. There's a huge range of things. Which are the ones that really are sort of driving this need for bigger data storage? I do want to contrast the cloud native, though, with this term cloud, right? Cloud aware. Cloud native is how we deploy and how the applications run and how they're orchestrated. Cloud native really talks, or cloud aware really talks about how the data might span across on-premise and multiple clouds. So I want to talk about the use cases there. And then I'll kind of culminate this by talking about how it impacts data storage, what offerings are out there. And I'll do just a quick introduction on our Tesca product, since it fits into that space. Let me start with these challenges. And I think for many people, if you think about the digital economy, think about all the businesses that have just become digital, right? I mean, it's so obvious in media and entertainment, where there's just this mass of videos, but it's really everywhere, right? It's in healthcare, it's in financial services. This has become kind of a cliche now, this massive growth of unstructured data. But I hate to do a presentation without at least talking about it, right? This data thing has become such a reality for us. And if you said it to people a few years ago, they would have said to you, well, data is documents, right? That might have been one answer, or data is database records. But now it's just so much more than that, right? I mean, it's your email. It's now it's IoT and edge data. Even your backups, right? Your backups that you have to take care of and protect for the long term, but images, media data, there's just no shortage of it. So I just wanted to kind of open up this realization that data is so prominent in what we're doing now from a business perspective. I know you've all seen these growth projections, but I think there's a couple of other notes just to be said, right? We all know that businesses today deal with petabytes, right? There's no surprise in that anymore. I think the kind of underlying surprise is that it's really shifted from transactional database-oriented data to more of document and unstructured type data. The other thing, to tie it back into our topic of cloud native, there was a study done by IDC where they said the data generated by cloud native apps is really the one that's going to grow much faster. And they found an order of magnitude more data from these types of apps than through traditional apps. And I think it makes sense, right? Because these are the type of apps that are going to deal more with the cloud and with lots of users and with media. So there's kind of a natural tie-in to me there. So, but this data growth problem is a real one, right? People need a place to store this data, and they need it to be cost effective. So we can't just brush this one under the rug. It's a genuine problem. The second one, though, is really the one that I think has hit us all in the last 5 to 6 years, right? And that is that data is no longer just in the data center. It's now in many more places, both being created and consumed. And I think it's just very apparent to all of us, right? I mean, most big companies today already have a multi-cloud strategy. I know that when we started talking to customers about it, the initial reaction would be, well, I have one cloud. I depend on Amazon. And then if you dug behind the scenes, you would find out, well, no, they have a SaaS product that uses Azure, and they have another product that uses Google, and so on, right? So there's these huge numbers being spent today on multi-cloud and on public cloud services. That already creates two locations. You have on-premises data centers and you have public cloud, okay? But now, here we are in 2021, and what are people talking about? They're talking about the edge. And if you listen to the big analyst firms, which I think are always a notable input, a big percentage of apps are now going to be put at the edge. In fact, that's where the growth is going to be. We're going to have in 4 years, half of our apps deployed on the edge rather than corporate data centers. And what is the edge? Well, the edge can be sports stadiums, can be hospitals, can be airports, can be a cruise ship, right? There's really a very wide definition to what that can be. And I believe it, right? We're starting to see more and more of this, and it can be everything from sensor data and the medical devices to end user data. It's really a very big variety. The last one, is kind of an interesting one, because this thing called the cloud paradox talks about whether or not we'll see big enterprises stay with an on-prem strategy. And I think for us, what we saw over the last years is that customers talked a lot about going to public cloud. And when they tried it, they ended up realizing the cost was pretty high. Okay, there were especially a lot of hidden costs. Things like the number of requests you make to a public cloud, the need to take your data out on what they call egress charges. That ends up adding up, right? And there's really a very big impact on companies to the point where, this very well-known VC firm, Andreessen Horowitz, just published a study that really talked about public cloud as being a big burden on company profitability. It's something like half of the cost of revenue and their valuation can be attributed to their public cloud spend. So this, comment that they made, you're crazy if you don't start in the cloud, but if they're crazy if you stay on it fully, really resonates. So I think this argues for more of this data is going to live everywhere observation that we started with, right? Both on-prem and in public cloud in a smart and intelligent and balanced way. Okay, and that brings us to the third one, and I think the one that's really very relevant, and then that's this whole thing around application modernization, right? And for the last few years, the industry, us included, we had talked about digital transformation. It kind of became the buzzword for many years. But I think now the big thing is there's a whole new wave of applications, right? These applications, these services that we all depend on daily, there's this big trend toward cloud native for that, right? So something like 2/3 of enterprises will start developing their own cloud native apps. And we think that a big percentage of new apps will actually be developed in this containerized, distributed, multi-services way. I mean, look at this example from JPNC, and they're clearly a high-end example, but they're all in on this approach. They stood up at Amazon reInvent just a few months ago, and they said they're doing a refactoring of 6,000 applications to cloud native. So it's massive, right? It needs a lot of developers. It needs a lot of talent. The other thing that we see is that artificial intelligence and machine learning are really becoming embedded in these apps to a very high degree. So that's going to be another trend. And I think that has a bearing on the data, right? Because AI and machine learning depends on training data sets and fast access to this data storage. So all of this is kind of a tsunami, I would say, that changes how we need to think about data and data storage over time. Okay, so I think those are the big trends. So now let's go down a level, right? What do we mean by cloud native workloads, and what are the ones that are sort of driving these new data demands? We talked about the edge, right? I think that's clearly going to be an aspect of what we see. Machine learning, we're starting to see more and more about this, right? Things like facial recognition, but also just in applied settings like in factories. We now hear about people deploying cameras. The cameras have to detect things in the manufacturing process. So there is an artificial intelligence machine learning process on looking at anomalies and tagging and metadata. That's going to be a big trend on data as well. From our perspective as a storage vendor, we have seen a huge growth in analytics. So these are applications like Splunk. Splunk is on everybody's mind, right? This is getting deployed in very large scale, but there are many other vendors like Vertica also selling solutions. You can even include things like Apache Spark and the whole Hadoop ecosystem in that. Another big driver of data, right? Media content, I think we all know how fast and growing this is. This is not just online delivery of content, it's also the need to store it for a long period of time. But now we're seeing more and more uses of the data, right? Like personal DVR, cloud DVR, real-time TV is another use case for big data that really has very high demands. And then the traditional ones, right? There's not a business in the world that doesn't need to think about backup and data protection. It's absolutely critical, and it's really what I think about when I think about an enterprise application. So combine that with all of this new variety of cloud services and SaaS, what do you see on the storage side? Well, you see a massive range of data. The data can be very small, it can be very large in terms of the individual payload sizes, but ultimately it's no longer a surprise to see individual businesses with tens of petabytes of data. This has a big change in the demand on the type of unstructured data storage that we had been selling for many years. Now the access patterns are going to demand high throughput, very high IOPS or interactive kind of performance, and low latency. It's a big change, especially from where specifically long-term archival storage was before. Now we need something that can deal with this more active data out of these different types of workloads that I just described. Okay, so now let's talk about how this all works on top of Kubernetes. So, this audience knows a lot about cloud native, containerized services and how they get deployed in Kubernetes. There have been interfaces published over the last few years for containerized services to interact with storage. And many of you will know the acronym CSI. This is the Container Storage Interface. This is an API or an interface for applications to provision storage from Kubernetes. It's really designed for provisioning block and file volumes. Okay, so it's very nice. It means that an application doesn't have to depend on a human actor. They don't have to call the administrator and say, give me a file volume so that I can access it from my app. It sort of gives this automated provisioning. There is an emerging specification for doing the same in the object storage side. And again, object storage is going to be a great answer for a large part of that big unstructured data that we talked about. So rather than CSI, this is COSI, Container Object Storage Interface. It's within the CNCF, and it's something that we think will be at a 1.0 ready specification later this year or early next year. So that means that we get automated provisioning for all of the different flavors of storage, which I think is really great. And since container-based services on Kubernetes love APIs, well, object storage is already a natural there because you have Amazon S3. It's a RESTful API. It's something that's being embraced now by application vendors, ranging from all of the different categories that we talked about earlier, and all of the storage vendors. We really have embraced the S3 API as a de facto standard despite the fact that Amazon is the real owner of it. Okay, so this makes it very, very natural for consumption from container-based services. Okay, so we talked a lot about trends and cloud native. Now I want to flip over a little bit to hybrid cloud. Okay, and so this is a related but kind of separate topic. What we're really seeing now is an increasing number of use cases that need the data to span across your data center and public cloud. It can be one public cloud and an on-prem data center, or it can be multiple. People might call that multi-cloud. The types of things that we've heard about they range from simple to sophisticated, right? Things like tier my data, take my data and put it in a cheaper cloud storage service, or perhaps move my data to something that is in a different geography, right? It gets more sophisticated in terms of rules. You might hear people say, move my data based on time, move it based on cost, move it to the edge, right, where the data gets created or gets consumed. And then really sophisticated ones like keep my data in specific regions because I have a regulatory reason or a compliance reason like GDPR, okay? This is really very wide, right? You hear lots of different things from lots of different people. So we needed a way to simplify that. There have been a set of very practical use cases, and I'll point out 3 of them that we've heard predominantly over the last 3 years. One of them you can think of very simply. It's cloud data archiving, right? So you have data, you're storing it on premises, you have your very fast file storage system or your object storage system, but at some point it gets full. So what do? You want to look at the data that's colder, dormant, less frequently accessed, and you want the ability to send it off to a cheaper place to store. Well, there are choices for that in the public cloud. Things like Azure has Glacier, Amazon has Glacier, Azure has their cold storage tier. There are others as well. A solution for this might be to provide a life cycle policy that moves the data based on an age rule. So for example, once your data hits 6 months old, tier it off and put it into one of these cheaper long-term cold storage services. That's a very practical and simple one. The next one that I'll characterize is a little bit different. You would think about this more as a cloud data bursting scenario. So here the difference is that the data is not dormant. It's not cold. In fact, it's very active and very hot in a way. So what you need here instead is to move this active data to some compute service, okay? And these compute services can vary. They might be an AI service or an analytics service, or you have media that needs to be transcoded or video content delivery. There's no, lack of choices here or scenarios for that. A lot of those services live in the cloud, like Amazon has EMR, Elastic MapReduce. It's a great analytics service. So what's the solution here for taking data that's on-prem and putting it in the public cloud? Well, something like a data replication policy could do this, where you specify the data that needs to be moved based on some kind of tag. So maybe the data says this is data that's today's hot video data, right? And I know that based on that tag, I need to move it to the public cloud for CDN, okay? So that's one possible rule, or it might be a filter. It might be to take only the data that got created within the last hour or something like that. But again, the difference here is I'm moving it for some active usage rather than the archival one. The third one that I'll characterize here is really for business continuance. So this is the need to keep businesses running, right? And we all think about this in different ways, but I think from a data perspective, people talk about disaster recovery protection, or DR for short. So what's the need here? The need is to keep 2 copies of data. What's emerging now is that rather than the old world where I kept a copy of data in data center 1 and another copy of data in data center 2, they were 2 physical data centers. Now people are turning to the cloud for that second data center, okay? So they want to keep, relatively synchronized copies of the data between on-prem and the public cloud. The solution here can be a form of continuous data replication. So as data gets written to the primary storage system on-prem, it gets replicated as near-term as possible to the public cloud. So what does that do? It gives us 2 copies of the data. What you'd like is them to be as close as possible, what the industry calls low recovery point objective, or RPO, so that if you need the data in the public cloud for business continuance, it's as caught up as it can be. Okay, typically this gets combined with the app being both on-prem and in the cloud. Okay, so more and more that's the need, right? So that you have a really hot standby scenario in the public cloud, okay? So again, there are solutions for all of these on the market, all of these different basic use cases. Okay, so we've talked about cloud native. We've talked a little bit about cloud aware. I want to take just the last few minutes before we go to the Q&A and talk a little bit about cloud native object storage. What does this actually mean? And you see the logo here for our test. I'll do just a quick introduction on that, not overboard. So there is an emerging space now for solutions that you could think of as both cloud native and cloud aware. They are in the object storage space. Object storage, again, it has these properties that the API-centric view, the API-centric consumption model makes a lot of sense for containerized applications, and it lends itself to this data that we talked about. This new generation of solutions is being built on top of Kubernetes. So what does it mean? It means that the architecture stack from top to bottom, things like API services and storage services and management services are all containerized. They all represent services or microservices, and they can be distributed anywhere. The key thing, though, is that they get deployed and orchestrated on top of Kubernetes. Okay, so they really fit into that world. If you have an application that also runs in Kubernetes, they can be co-located, they can be separated. So it gives a lot of flexibility and choice. What's the reason for doing this? Well, the real primary reason is to make things portable, right? This gives us a way to have storage that lives in the data center, in the cloud, and on the edge. And that's great, right? Because it gives sort of this uniform model for managing storage and applications together in the same way over and over time. We did announce our product, Artesca, in this space just a few months ago in early 2021. And again, it kind of fits this requirement model that we've been talking about. I didn't mention cloud aware, but I'll just show you a quick screenshot of it. So what does this cloud aware mean, in terms of a practical product offering? Well, what it means is that you have the ability to have your namespace for your data live locally or remotely, and those remote data sources can be public cloud. So, for example, I could have data that's stored locally in this case, in an Artesca instance. It could be in a remote object store, could be Scality's Ring or Ceph or another S3 compatible object store. But it can be public cloud. It can be Amazon. It can be Google. It can be Azure. It can be Wasabi. And there is also a generation of S3 compatible tape devices coming up in the system that people really still like for very cold, very cheap storage. Okay, so that's what it means to be multi-cloud aware and to have the ability on top of that to run the lifecycle and replication policies that we talked about earlier. Okay, in terms of the policies for data management, it really starts with that global namespace, but the tangible data management policies part of that really means the ability to lifecycle data. That means delete it or move it based on rules, to replicate the data from source to target. It's a great model if you're developing something from edge to core, is what people are starting to talk about. You might have an edge object store and you set a policy that says keep the data there for 90 days, but then move it off to Amazon. That might be a classical policy for that. Okay, so I think in summary, we've kind of talked on a lot of points here, but I think it's driven by this whole new world of cloud native workloads. We're just seeing so much more, AI, ML, analytics, edge applications that are driving new demands on data storage. And I think the cloud native model just needs to be embraced. And I think overall, it really provides us with a solution that can offer this kind of portability that we need to build this new class of applications. So with that, I want to thank you. And Tom, if there are any questions that came in the meantime, we can certainly take those right now.
All right, Paul, thank you for a great presentation. That was very learningful, as usual. So I do have a couple of questions. One question I got was, what type of applications are you mostly seeing customers deploy now on Kubernetes?
Yeah, it's actually a surprise to us, right? Because we would have thought that it would be just very forward-looking institutions, like research or advanced technologies divisions, but we're actually starting to see it in the mainstream now. And I think the one thing I want to say is that it's heavy in the analytics space. So applications like Splunk, very much now being deployed in Kubernetes. These classically were on-prem apps. They've moved to the cloud, but cloud native is the way for them to get that portability. I would say the other change that we're seeing is that the decision makers behind that are more application teams, not so much traditional storage admins. So it's the application team that owns the business problem. So they'll have something like a data lake that they need to create. They find the app. It could be, Splunk, or I mentioned Vertica as well. That seems to be a very hot area. AI and ML in many manufacturing locations is another one. So those are the two that I would point at as very dominant right now.
Okay, awesome. And then I want to dig a little bit deeper into the stack. What Kubernetes environments do you see mostly in deployment?
Yeah, there's a big variety growing out there, right? So for many years now, we had heard a lot of people talk about Red Hat's environment, OpenShift, which is obviously now IBM, right? So that's a predominant one and it's been out in people's hands. There's a lot of buzz around the VMware Tanzu environment, and we are starting to hear more from customers around that. Tanzu has the additional advantage that it has its own storage pool capability called vSAN. And that gives another advantage because it lets us converge the storage for many different things, including potentially the object store. We hear very good things about the Rancher environment, which can be both a Kubernetes or a management layer on top. And then there are others. Every vendor has their own different flavor, including HPE, which has Ezmeral. So I would say those are kind of the top 3 or 4 that we hear about a lot.
Yeah, all right, good. So you and I could probably fill several hours of stream here on storage performance, and I don't want to do that, but still one question. Are you seeing a need for object storage on flash, like the higher performance object storage, or is it rather like just regular block and file?
Yeah, we are starting to see a demand for it. And again, you have to look at the driver for it, right? What is the need for flash? Well, flash traditionally has been great at performance, like very high IOPS in a small footprint and also low latency. From a low latency perspective, I would say that there are really demanding video applications that need totally bounded latencies. I mentioned live TV and cloud DVR. This is where latency matters to them. So that's a big one. Flash also has a big benefit for throughput. So for these memory intensive applications in machine learning, they have a need to blast a lot of data into memory so they can process on it very quickly. Flash has a benefit there, right? The lower the latency, the higher the throughput, it really adds up for these applications. So and I would say ultimately the price point of high density flash is now getting to a tipping point where we can do high capacity and low cost. So it makes a lot of sense for these workloads.
Yeah, I think when we started in the object space 10 years ago, we wouldn't have thought that this was going to happen, but this is really amazing.
It's caught up, exactly.
Yeah, awesome. Okay, Paul, as always, this was very learningful and it was always good to have you on a webinar like this. If anyone, when they're doing the on-demand viewing, have any additional questions, please post them in the comment section. We will monitor and we will definitely come back to you. Paul, we kept it under the half hour as we were planned. So thank you very much for a great presentation. Looking forward to the next one. And to the viewers, we hope you enjoyed it. Please subscribe to the channel so that you can be kept up to date on future streams that we have for you. And with that, thank you so much. Have a great rest of your day.
Thank you.